Okay, we're given a sequence here, and we're being asked if it converges or diverges. In this case, and in any case in which we try to find if a sequence converges or diverges, we try to find the limit as n approaches infinity. So the limit as n approaches infinity of this sequence is what we try to do. So the reason we do this is to see what kind of behavior it has as you go all the way to the end in indexicality, never actually reaching the end, of course, because it's infinite. It's an infinite sequence. So how do we actually solve this one? This one's a little tricky because you have to really reason your way through this. And it kind of took me a while. But the way you do it is, first you look at what's inside. What's inside of the radical? You've got n³ plus 4n. n³ plus 4n. So let's just look at that portion by itself. n³ plus 4n. Now, what happens when we plug in infinity? If we were to plug in infinity, this would be infinite, right? And this would be infinite. So it's not really telling us anything. We can't really conclude if this will converge or diverge. So that's a problem. So we need to try to do something with this. One thing we could do is bring out the n. Bring out the n because we could factor. We could factor in n, and then we have n² plus 4. This is all inside of the radical. Now, we could bring this out of the radical. This is n to the power of 1/2, because that's what the radical does to you. And then we've got n² plus 4 still within the radical. Where's my eraser? Now, we have this in the denominator under n². Under n², and this is what the limit as n approaches infinity. We could further simplify when we have a power here in the denominator and power here, we could subtract from the numerator. So this is the limit as n approaches infinity of 3/2 of n to the 3/2 over, and we still have this square root of n² plus 4. Now we can further reason our way through this and notice that the 4 doesn't really matter. The 4 doesn't really matter because we're plugging in an infinite quantity here. We're going to infinity. And if we're going to infinity, adding 4 doesn't make a difference. So we might as well not even have that. We might as well not even have a 4 there. And so therefore, we could just look at this as the limit as n goes to infinity of n to the 3/2 over the square root of n². And the square root of n² is just n. It's just n. Now we have, again, we could subtract. This is to the power of 1. You subtract 1 from 3/2, and you get 1/2. So this is the limit as n approaches infinity of the square root of n. And that is just infinity. So this diverges. We know that we didn't get a real value. We didn't get a value at the end. So that means it diverges. It does just go to infinity.